class.
Hello.
I decided to wear my skeleton outfit today because we are going to be talking about subject factors. And these factors involve the patient and selection of technique that compensates for the patient's size, shape, and tissue composition. Subject factors include subject contrast, patient thickness, KVP, tissue mass density, effective atomic number, and object shape. All of these factors affect subject contrast. So first, I'm going to talk about what subject contrast is. Subject contrast is the component of radiographic contrast determined by the size, shape, and X-ray attenuating characteristics of the subject who is being examined and the energy of the X-ray beam. Next, I am going to talk about patient thickness. Thick body parts attenuate more X-rays than a thin body part, such as my hand versus my abdomen. More X-rays transmitted through thin body parts, and the degree of subject contrast is directly proportional to the relative number of X-rays leaving those sections of the body. So class, who will attenuate more X-rays, a hypersthenic patient or a asthenic patient? Yes, Amy?
A hypersthenic,
And why is that?
because they have more tissue for the X-rays to be absorbed.
That is correct. Next, I'm going to talk about tissue mass density. Different sections of the body can have the same thickness but different mass densities. Here are two examples of tissue mass density. The next subject factor I'm going to talk about is the effective atomic number. Subject contrast will be high when the effective atomic number of adjacent tissues is very different, or with the use of contrast media. So, Stacy, what are two types of contrast media that we use in the X-ray field?
Barium and iodine.
That is correct. Girls, no selfies in class. It's time to focus. The next subject factor we're going to talk about is object shape. When a structure's form coincides with the X-ray beam, there is maximum subject contrast. An object that has the shape of an isosceles trapezoid will have maximum subject contrast, but any other shape, such as a circle or a square, will have reduced subject contrast. The shape of the object being imaged contributes to absorption blur. Absorption blur reduces contrast and spatial resolution. The final subject factor is KVP. KVP is the most important influence on subject contrast. Low KVP has high subject contrast. So Amy, what kind of grayscale is this? Long or short?
True. False. Yes. No.
Girls, I know this is kind of boring, but I really need you to answer my question. Is it long or short grayscale?
Short.
Short. Okay.
Long.
Short.
It is short, right?
Yes, Stacy, you are correct. It is a short grayscale. A disadvantage of low KVP is the higher patient dose because of the need for a higher mass. On the other hand, a high KVP is low subject contrast. So, girls, what kind of grayscale is this? Long or short?
Long.
You are correct, Stacy. One more topic I want to go over is motion blur. Motion blur is the loss of radiographic quality because of patient or X-ray tube movement during the exposure. Patient motion is usually the cause of motion blur. There are two types of patient motion, voluntary and involuntary. An example of voluntary patient motion is movement of the arms and legs, and an example of involuntary motion is the heart beating. To reduce patient motion, the shortest exposure time should be used. Clear instructions should be given to the patient. A restraining device can be used. Utilize a large SID and the smallest OID possible. That's a wrap. But wait, I have one more question for y'all. Why didn't the skeleton cross the road? Because he didn't have any guts. See y'all later.